Hello everybody. Today's lab we are simulating a half-life, and we're simulating that using dice. Now for the level 1 in honors, you're going to have to read the front and you're going to have to complete the first couple pages. Now it says pre-lab. You're not really doing it as a pre-lab. You are just going to be doing this as part of the lab, and then you're going to hand it in when the lab is due. It's really just a matter of looking at data and interpreting graphs. Now for the lab itself, and this is for all levels, we are going to be working with dice. Now the idea is I'm going to give you a decay number, which is going to be 1 through 6, and we're going to count every time that number comes up through a series of rolls of the dice. So let's say the decay number for this activity that I'm demonstrating is a 1. Which means I am going to count the number of times that 1 comes up in a set of rolls. Now each round is going to represent a total number of rolls. So round 1, I need to roll 100 dice. I do not have 100 dice to give to each group. That would be like 1,200 dice. It's not going to happen. I do have enough dice to give every group 5 dice. So we are going to roll all of these in sets of 5 until we reach 100 dice. So what that means is I'm going to roll 20 sets of 5. Now with each set, with each roll, I'm going to count the number of times that 1 comes up. So 1 comes up 0 in the first roll. It comes up 1 time in the second roll. It comes up 1 time in the third roll. Comes up 1 time in the fourth roll. And I'm going to continue this until I've rolled a total of 100 dice. I'm then going to add up all of the times that the 1 has come up, and I'm going to put that number here, number of dice that decayed. So let's say 15 times that number 1 has come up. I'm then going to do 100 minus 15, and I get 85. So I now have 85 dice remaining. So of the 100 that I started with, 85 remain, because the 1 that came up, we're counting that as a decayed dice or die. So now this 85, for the second round, I need to now start with 85. So I'm going to have to roll these 17 times, okay? Because 17 times 5 is 35. So the 1s came up 2 times. The 1 came up 1 time. The 1 came up 1 time. And I'm going to continue this on until I've rolled a total of 85 dice in sets of 5. So let's say now, this time, 11 have decayed. So 1 has come up 11 times. It's going to be 85 minus 11, which is 74. I now have 74 dice remaining. So the 74 goes here. And now I need to roll in sets of 5 and see how many times the 1 comes up. 0. 0. 3. Now the thing is, this number is not divisible by 5, okay? So what I'm going to have to do is I roll in sets of 5. So I've done 3, so that's 5, 10, 15, 20, 25, skip a bunch, 65, 70, and then the last round I only roll 4, and then that totals 74. So dot, 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 I total this up, and let's say 10 come up this time. So 1 appears 10 times out of those 74 rolls. 64 remain. I now have to roll 64 dice in sets of 5. 5, 10, 15, 20, skip a few, 60. The last one I'm going to roll 3 to a total of 4 to a total of 64. And you're going to keep doing this until I've done 20 rounds or until no dice remain. Okay, the final thing you need to do for this lab, once you have all your dice rolls completed, is you need to graph the data and create your decay curve. So what you're going to do is you're going to manually type in all of the data you collected into a Google Sheet. First column A is going to be round number. Second column B is going to be the dice remaining. The directions do say to include a point for 0 rounds with 100 dice remaining, which is not in your data table, but we want to include that just so we have an extra data point. You're going to insert a scatter plot, and you're going to get something that looks like this. Now you have to be careful, because when we come to do our trend line, we're going to come up here, and so we're adding the trend line, but you notice it's not linear this time. If I choose a linear trend line, look what happens. I have an R-squared of 0.769, which is horrible. I get a straight line that looks nothing like the curve of the data. This time, I'm actually choosing an exponential. Now what happens, my R-squared changes to 0.995, so that's a significant improvement. And I get a line that really represents the data pretty well. So make sure you choose exponential. Now also, on the round number, you really should have the major go by ones. So in order to do that, you're going to go to grid lines and ticks. And for the major grid lines, it says up here major spacing type step. You're going to want to put a step of 1. It's going to want to immediately put a step of, I think 5 is what it does. You don't want to do that, okay? If you want a step of 1, because I'm going to want to read this graph. And then you're going to need to make sure you add your minor grid lines. I added a minor grid line so that it goes by half, and I think that is appropriate. The y-axis, you can adjust this. I think going by 5s is perfectly fine, and make sure you have an appropriate title. You do not need to include the equation, but I do want the r-squared on the graph. Now, what you're going to have to do once your graph is done, you are going to snip this. You're going to make a cut and paste, and you're going to cut this into your final document after you have done all your work. So you're going to submit this so that it is in that document, just like we did for the other graphing lab. But I'm going to have to use my graph to get a half-life. Now the directions for question 3 says use your graph to determine the half-life. You're going to choose 2 points on the y-axis where the first point is twice as large as the second point. So for example, 80 and 40. So it could be 80 and 40, it could be 70 and 35, it could be 90 and 45. It really doesn't matter. You just choose 2 points. So I'm going to choose 70, which is right here. I'm going to go across until I hit the line, and then I come down and I'm at about 1.5. So I'm going to put 1.5 right here. That is the corresponding x value for my y value, which was 70. Let me move this. This was 70. So this was my y value. Hope if I could type. And this was my x value. Because I chose 70 as my y value, I want to now choose a point that's half that, 35, because half-life is the amount of time it takes for half a sample to decay, or half amount of dice to decay. So now I'm going to go to 35, which is right here. So 25, 30, 35. I go across until I hit the line, which is right about here, and that's at about 5.3. This is why it's very important for you to have your grid lines on here so that you can estimate and use the graph so that you can get your values appropriately. The difference between these two numbers is going to be the number of rounds it takes for half the sample to decay. So your half-life, it might be similar to mine, it might be a little different. I have here 3.8. So 3.8 rounds is what it takes for half the sample to decay. Now you can think of a round as like a year or a minute or a second. So if we were dealing with a half-life in years, it would take this sample 3.8 years to decrease its amount by half. So you need to do this with one set of points for y values, so one that's half the other, 70 and 35. And then you pick another one. So maybe you want to pick 50 and 25. Or 60 and 30. So you pick another two y values where one is double than the other, read the corresponding x values. The difference is your half-life. You need to do this 2 times with your graph. Okay, so then you're going to use your half-life to answer a couple questions, and then you are going to submit the lab. So good luck.